how do you see the Volt system being used? Is it going on the procurement side? Is it going on the engineering side? Is it going in various different elements of the organization? Where do you see it living inside an organization that batteries are critical to what they're building?
It's like you say there, it actually sits within multiple different departments, and that activity of cell selection, as you say, it's used by procurement, it's used by the concept team, it's used by the pack team to come up with like pack concepts after they've sort of selected their cell. It's also actually used by the sales engineers, because the sales engineers for a pack design company, they need to sell battery packs and they need to be able to, answer a customer's RFI or RFQ very quickly. So being able to prototype that on the Volt has been really useful for them. So yeah, what we find is it's often used between about 3 and 5 different departments within a company, um, the whole way from sales to procurement to engineering.
I mean, that's the, if you want to call it the corporate side, but let's go to the fun side. And engineering race cars. Are you seeing any teams trying to use this data to quote unquote get a competitive edge in a race, whether it's a sanctioned race or it's just for fun? Are you seeing the motorsports industry look to this data?
Yeah, for us, some of the motorsport teams are the most advanced. Um, like I was lucky enough when I worked at Aston Martin to work on something called the Valkyrie hypercar, which Aston Martin built with Red Bull Racing. So I got to go to Red Bull Racing, the Formula One site, and actually meet some of the Formula One engineers. Was in the same office as Adrian Newey, who's one of my hero um, mechanical engineers. And I got to see in Formula One, they're restricted in terms of how much real world testing they're allowed to do to try and keep a cap on the costs. So they do a lot of simulation, a lot of model based design. I remember going to see the Formula One simulator where they can actually drive the car in the simulator that's powered off of Simulink models. And they can then adjust the Simulink models, like the suspension parameters, and then the Formula One driver can give like real time feedback. So Formula One take model-based design to the absolute extreme, and that's sort of true for a lot of the motorsport industry. So for us, they're perfect customers because they understand the value of model-based design. They do it in everything else, and they just struggle with it in batteries. But that's where our data and our simulation models really enables them. But yeah, they've been perfect early adopters because they understand the value of it.
Then how about if you go into the hypercars or the collectors, like that other aspect of the market? Then you have the amateur racers. Are they starting to look into that data as well?
A little bit, but not so much because a lot of smaller amateur racers, anything electric, they're going to be buying in a battery pack from somebody else. So you've got big sort of tier one battery pack developers for motorsport applications like Fortescue Zero, who used to be Williams Advanced Engineering, and also Podium Technology. So there's a number of different companies around the world that make battery packs for motorsport applications. And often the end users, whether it's Extreme E or Formula E, often they're not the ones actually building the battery packs themselves.
That's interesting. So over time, how light do you think batteries will get?
But they're definitely going to get lighter. Every year they get better and better. It's, in semiconductors, we have Moore's law, which is every 2 years they sort of double. It's not quite that good in batteries, but I think we're talking probably, from my analysis, it's like anywhere from 10 to 20% every year they get better, which is incremental year on year, but over a 5-10 year period, that adds up to be quite material. So I think realistically, we can expect in the next like 10-15 years for battery packs to be like a half or a quarter of the size they are today. And it's not just about the raw energy stored, it's also about the integration and getting the most usable energy out of the battery pack that exists, and also the software that goes on top of that. Like you've probably heard of things like fast charging, which traditionally damages and destroys a battery pack, but with clever software, you can actually prevent that from happening. So there's a lot of innovation, not just at the material level, there's innovation at the pack level and the software level that enables extra performance to be squeezed beyond just chemistry innovation.